Yo. How you guys doing? It's your boy Malik, and welcome to episode 1 of Tech Trek, where I am going to be sharing my lessons learned along my programming journey on a weekly basis while we are here during the quarantine. So in this inaugural video, I want to go through a few things. Just one, introduce why I'm actually even doing this thing that I'm calling the Tech Trek. Two, to go through my plan and how to execute that, as well as giving you guys a little bit of background on me and how this all came about. I'm grabbing my iPad now so I don't forget what I'm gonna say. And then 3, go through the actual lessons learned from this week. So a little bit about me. I am a product marketer by trade. I'm an aspiring product manager, and so over the course of the next year or two, I plan to actually pivot into PM officially, but I just love building products, right? I've started businesses in the past. I've done a lot of side projects where I've created websites and different types of services and things like that for people to use. I just think it's the most exciting thing. But when I was working on my last startup idea, which was an online learning platform, I ultimately came into a major blocker, which was that didn't have a technical founder on the team, and that made it difficult to get things done. And so I took a step back and I was like, whoa, dude, I like building products. That's my thing, right? If that's what I want to do, I will always be at a marked disadvantage if I don't understand technical concepts and I'm not able to execute. And so I realized that, you know what, man, let's hit pause on that. It's fine. I'm young. I'm in the apprenticeship phase of my career right now, and so the number one thing that I want to prioritize is my ongoing learning and development. And so thinking about what would be the most important things to learn, learning software engineering came to the top of the list because it's essentially a form of permissionless leverage, right? With this, you can do so much at scale, and it's such a valuable tool because you have the internet and an army of robots at your fingertips. So I'm hey, dude, I'm gonna go in this thing, and my goals are to, number 1, learn the first principles of good software engineering, and number 2, learn the tools that I need to explore my creativity and my product ideas without bound. And so that's where this whole Tech Trek idea came about. Since I'm in quarantine right now, and I hope all of you are doing well, I figured this would be a great way for me to force myself to share my learnings and kind of have a virtual study group and all of this kind of stuff. So that's where this all came about. So my actual plan, how am I gonna do this, right? So I do have some basic programming experience, right? I majored in information systems in college, concentrated in UX design and basic web development, and so I'm very familiar with HTML, CSS. I've taken intro Python, intro Java classes throughout college. I've built a ton of websites, a ton of WordPress websites and all this kind of stuff. So I do have some general understanding, but in terms of how to actually program and really understand the way of thinking, I think I have a lot to learn there. So my plan is broken into 3 phases. Number 1, I'm going to take all 3 of the Stanford Engineering Everywhere courses. And so that includes programming methodologies, programming abstractions, as well as programming paradigms. And the goal of taking those courses is to really develop an understanding of the first principles of software engineering, and Stanford is known from that. So it's a free course online. I'm dude, let's take it like it's a real college course. Number 2 is to then pivot to educative.io, which is a text-based online learning platform with integrated IDEs and stuff. Huge marketplace of courses, really cool. You get it for a yearly subscription of $250 or something. So I'm gonna then, after finishing those courses, pivot to the scalability and systems design track. And so the goal of that is to really understand how our systems built, right? And how do you understand how all these components talk to each other, right? The front end, the back end, the database, understanding microservices, the different type of architectures that you can use, and how do you scale up and scale out and all this kind of stuff. So I thought that would be important to understand. And then finally, I'll take a course that's specifically focused on or a series of courses rather, that specifically focus on front-end development and React. And so let's start with the first principles, right? Let's understand systems design and how everything fits together. And then let's learn the nuances of this specific language that I could then use for whatever I want. All of these courses have a lot of projects that are already built in. So it's going to be not just me like taking and downloading a bunch of information. There are projects that are going to happen throughout the process. So I'll get a chance to actually apply that knowledge as I'm learning it. Okay, so that's the tech trek. That's the plan. Today, I just started the very first course, not today, but this weekend, I just started the very first course, which is Programming Methodologies, CS106A, and I'm going to go through what I learned this weekend. All right. Okay, cool. So let me actually, like, this is so hard. I'm just going to hold my iPad. This is like, I'm trying to, remember what I'm going to say. Okay, so in this course, it's a Java-based course, and basically, like, the first week of the coursework is focused on introducing you to this robot that you're going to be playing with to learn some introductory Java concepts. And that robot is called Carol. And so Carol exists in this environment that's like a 1x1 coordinate plane, XY axis, right? And like you can move them around. There are objects which are called beepers that you can pick up, put down, put them in a bag, that whole thing. There's walls and like different obstacles that exist as well. And so your challenge is to like make Carol do what you want, make it move around, make it pick up a beeper here or put it down somewhere else, or like pick up a whole row of beepers and all this kind of stuff. And so it kind of takes this very simple example and shows you how programming works and how you can kind of get started. And I've really enjoyed it so far. And so with the first couple sections of the lesson plan, the first thing that they did was explain the rudiments of object-oriented programming. So they're just like, hey, there's like procedural programming, the procedural paradigm, right, where you kind of focus on a set of operations that are executed in order. And then you have object-oriented programming, which is essentially focusing on these conceptual abstractions called objects and how they all integrate together. And the reason that's important is because with objects, you can now kind of play around with like the state of the object and the behavior as a result. And so like the state is like the attributes, right? So anything that can change over time. So location, space, color, whatever. The behavior is how this object like responds to its world or to the behavior of other objects, and like anything that triggers a behavior is a message, okay? So they kind of explained that. They also talked about methods, which is essentially telling the robot to do something, right? So when you're invoking a method, it's just like, hey, go do this thing. You know what I mean? So I'm like, oh, okay, cool, I got that. And like they basically explained like, you know, objects and classes and all this kind of stuff. And so once you kind of understood the syntax, you're like, okay, cool, I got a feeling for how this thing works. I'm ready to like now start getting into the meat of it. So from that point, they move on to the second lecture. And in the second lecture, they basically introduced a few core programming concepts. And I like this lecture a lot because when I was like calling all my software engineering friends, I'm like, hey dude, like, what should I learn? What do I need to figure out? They're just like, there's a few concepts that you want to remember, right? Like, you know, encapsulation, they said, was like super important. Understanding abstractions was super important. Understanding inheritance was super important. I don't know anything about that, but I know it's important, so I'm like, okay, you know, my reticular activating system is going to remember that, you know? So in this second section, they actually talk a lot about some of those concepts. So they talk about encapsulation in the sense that, you know, we got to a point where, like, you feel certain classes are going to be, like, public and then others are going to be private. When you're writing them, it's like, why is that the case? Well, we found out that, like, the best practice is to encapsulate the information in your program wherever possible, because this allows you to reduce complexity and then also like restrict access to the information. And so I'm like, okay, cool, like I'm getting that. I can get why that's like super important. Like they gave the example of a car, right? Like when you start a car, there are all these dependent operations that have to happen, but you don't see any of that, right? And so like you're kind of just like, you know, doing your thing. But there's all this machinery happening in the back end that's essentially encapsulated, right? So I'm like, boom, got it. The next thing they kind of talked about was actually inheritance, because like when we were like programming this robot, we were extending the library, a library that already existed, and pulling certain functionality from that, right? And so inheritance is essentially taking the structure or behavior of like a parent class, right? And like building on top of that. And when you do that, you get like this subclass which can like pull from the parent class and also add cool new functionality on top of that. So I'm like, boom, that's dope. And then we also got into decomposition and like stepwise refinement. And essentially that's exactly what it sounds like, right? It's like breaking a problem or a program down into its sub-problems or component parts so that you can manage the complexity and then also make it easier to scale and also easier to understand. And so on the surface, I was like, yeah, that makes sense, right? It's kind of like, consulting, MISI, like breaking things down, whatever. But like, when I actually started doing the problem sets and playing around with it, I was just like, oh, I see how this can get very, very tricky, because you have to know like, where do you decide to like, where's the break point to like break things down, right? Like how do you actually decompose a program? And so that reminded me of a principle that I learned earlier, which is the separation of concerns principle. So it's essentially saying that like each subproblem in a program should actually perform one specific generalizable task. And the reason why this is important is because it now helps you... the reason why it's important is because it essentially makes it helpful for you when you're dealing with edge cases. When like you have the program, like what this thing is doing is like general as possible. Like it can maneuver in a lot of different situations, and then it also makes it more scalable. And then when you want to go back and like make edits, because oftentimes you have teams of software engineers that are working on something, it makes it easier for them to go in and like boom, 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 do what they need to do. So that was super cool to understand, and I feel like I got a good like intro, little tiny primer into these concepts. And then the final thing that they did is like, hey, now we understand the basics of object-oriented programming. You know some syntax, you know how things kind of like work, you know methods, decomposition. They built on top of that and said, instead of just like creating a set of predefined commands for this program to execute, how do you make it so that this program can examine its world and its environment and actually respond? And so that's where we get into conditional statements and iterative statements. And so the conditional statements are just if-else statements, which is like, hey, if this condition is met, I need you to do this. Otherwise, I'm gonna need you to do that. And then like the iterative statements are then it's like, hey, I need you to do something a certain amount of times, or I need you to do something as long as a certain condition is met, right? And so that gets into like for loops, right? Or while loops. And so beyond that, we just did like a couple problem sets that allowed us to kind of build on top of those concepts and actually apply them. And so this week I wrote about 70 lines of code. It was cool. I had my first couple of brain farts where I was like, dang, this looks so easy when I read it in the book. But about that. And it was cool. I felt like, I kind of am starting to kind of get my feet wet and all that stuff. So we're about 3 lectures in. Going to, I think we read about 39 pages, the complete intro to Java book, intro to Carol with Java book. But yeah, so far so good. Next week, I'm going to start reading the Java textbook, and I think we're going to start getting into some more advanced topics, and I also have my first assignment due. So check back in on episode 2 of the Track to see how that process goes, and I will continue to keep you guys updated. Peace. Fire, fire, fire. Pew, pew, pew. Super hot. Super. Yeah.